Hi, I'm Glenn Lockwood, and I'm Principal Technical Strategist at Vast Data. As AI is taking over the world of HPC, we're seeing a lot of our customers start focusing on more than just pure performance as the sole requirement for their data needs. And so, for example, customers are looking for data governance features, or data protection features, or reliability features that allow them to get more out of their systems than purely the big number. And so, for example, how good is it getting to the result as fast as possible if that result is not trustworthy? This is a question that more and more of our customers are beginning to ask themselves. And so features like data governance and provenance and understanding what data went in to train a model that produced an answer is becoming just as important as how quickly could we get to that answer. AI does have a lot of non-deterministic or messy data associated with it, and typically we find ways to support both. I think a well-designed data platform does both unstructured as well as structured data to support both the raw data that is, for example, scraped off the internet or streamed in from scientific instruments, which is then converted into more structured formats that are suitable for loading into models that are being trained. And so we're seeing a strong demand for both high support and good support for unstructured data, like files and objects, as well as very high performance in structured formats like insert rates and selected query rates like that. So the implications of moving from file to object are really around usability balanced with all of the data governance features that are becoming increasingly important in AI and scientific data. And so, for example, files have a very primitive understanding of ownership. A file has one owner, it has a UID, it has a group ID, and it has a very primitive set of permissions. Whereas objects have much richer permissions. Objects can have life cycles attached to them for governance purposes, and objects just have much more expressivity, but they are harder for people to use. And so we're finding objects become much more relevant in highly automated pipelines, whereas experimentation by humans in the loop tend to map better to files. But as data grows and grows, automation is essential, and that's where objects become increasingly important because they are easier to automate and manage through automated pipelines. So I did maintain IOR and MD test for a number of years in past lives. And while they are great at measuring one big number, that's only one dimension of the overall value that a storage system, for example, provides. And so they are really evolving from a state where they were the one true benchmark into one where they're a tool to measure one dimension of a much more complex design space. And so IOR and MD tests still play a role, but it's critical for the people who use them to understand what their limits are and what the number they're actually telling you as a benchmarker really mean in the context of how will that number affect day-to-day performance and day-to-day throughput and efficiency of the overall system that you're using with that storage system. I'm not sure that AI workloads will become the de facto benchmark because AI, just like HPC, is not just one workload, it is a diversity of workloads. And what makes AI workloads even more challenging is that they are changing on a weekly basis. So the breakthrough model of today might be old hat tomorrow, and there might be a new model with a new architecture tomorrow that has very different demands on data and computation and the way that those two are integrated together to train and inference. And so I'm not sure that there is one true benchmark, whether that be HPC or AI, but we will have a growing suite of benchmarks of which AI benchmarks will become an essential part. I think the HPC community needs to understand and appreciate that there is a richer world of data beyond just files. This community has long grown up on the parallel file system because HPC came from a world where scientific computing was driven by physicists sitting at terminals. And nowadays, that simply doesn't scale. The volume of data being generated both in the AI space as well as the scientific space far exceeds what a human can realistically manage at a terminal through a file system. And so moving to the world of object and moving to the world of structured data, such as structured databases, offers much more opportunity to manage that data in scalable ways with much better automation. And that allows greater productivity and divorces us from having a human in the loop every time we need to interact with data.